of surface. This temperature of about 16,000 Kelvin is at the surface of the sun. The ultimate temperature is even more. Then at this temperature it behaves as a black body, and which emits all the radiations of the electromagnetic waves there. And energy, the light and heat what we receive from the sun on the surface of the earth is basically known as solar energy. So, as per available data, current available data, if we capture the 1 hour of solar energy which we receive from the sun, then it is sufficient enough to power the whole world for 1 year. So at least we can imagine that how much energy we are receiving from the sun. Then where is the problem? If this much of energy we are receiving continuously, then why people are worried about this energy crisis, energy savings and all these things? The problem is that how to harness this energy, how to capture this energy. So there are lots of technological issues because of which we cannot capture this whole energy for our practical applications. In my presentation, I am going to discuss and going to explore some of the technologies which are being used to capture or harness the solar energy. So these are the content of my presentation. First, with the help of flow diagram, I will show the various routes for solar energy harnessing, and then these two technologies are usually used to harness the solar energy. One is solar thermal technology, in which I will discuss solar water heating system with the help of the two devices. One is flat plate collector, abbreviated as FPC, and another is evacuated tubular collector. Then solar air heating system with the help of a solar dryer. I will try to show that how it has been used to heat the air. The third one is solar distillation, solar steam. The participants already discussed a lot about the solar distillation. I am going to discuss the solar distillation. Then solar cooker, so very simple and very useful device, especially used in rural areas or areas where electricity is not available or very rarely available. Then last in this solar technology is solar thermal power plant. Solar thermal power plant. In this we use the lead content of the sun to generate the electricity. There are two ways to generate the electricity basically from the sun. One is the solar photovoltaic technology, in which we directly use a device called solar cell, and the photon falling on it is converted into electrical energy by basic principle, that is photovoltaic effect. In this, then the solar photovoltaic technology, as I said, is a very simple technology, and in which I discuss standalone system and grid connectors. So these are routes for solar energy. These are the some of the possible routes. There may be some others, but the solar thermal technology, depending on the temperature we achieve, our temperature of the fluid we achieve, we have three types of applications: low temperature applications, medium temperature applications, and high temperature applications. Then second is solar photovoltaic technology, where we direct, as I said, the energy we receive from the sun is in the two forms basically. One is light and another is heat. In solar thermal technology, we use the heat content of the sun's energy for various applications. So first one is solar water heating system. We use the sun's energy to heat up the water. So in solar water heating system, two very famous devices are, one is flat plate collector and another is evacuated tubular collector. So flat plate collector is the basic design, the old design you can say. It consists of a rectangular wooden box painted black inside, and on the top surface glazing is there. Glazing glass cover will be there, and inside it three kinds of tube you can say are the copper tube of three different diameters are being used. One is known as the header, the lower one is footer, upper one is header, and These basically are known as the rises. But when the hot water rise in the field. And second one is the evacuated tubular collector. In this, the overhead tank first is filled with the water during the night, and these are the hollow tubes. And evacuated has been created between the two layers of the glass to make it insulated. Because if no air is there, no medium conduct the heat, it will work as an insulator. Then the overhead tank will be filled with water, and the tube, this tube also will be filled by the water because it's the hollow one. Then in the day, sunshine hours, sun radiation falls on it, it will transmit it will transmit to the water inside it. The water gets heated, and you know, as the temperature of the water molecules increases, it becomes lighter, and because of the weight, it becomes lighter. It starts raising the tube, and the place of that lighter molecule will be replaced by the heavier molecules which are comparatively at high temperature. By this process, the water goes alive in the tube, and this process continues unless the water temperature at each and every point of this system remains same, becomes same. This is the flat bed collector. In this, as I shown, these are the two collectors connected in series. So in this design, blazing will be there. The sun radiation falling on this blaze will be transmitted, and it gets absorbed by the absorber, that paint. Then it starts radiating its heat to the tube. The copper tubes are there, metallic tubes are there, and then water inside the tube gets heated. As water gets heated, again it becomes lighter. It starts blazing in the tube. The point of the system becomes same. Unless certain temperature gradient will be there, only water flow will be there. So this first one is the electrical execution part of the absorber plate. In the left hand side is basically the total solar radiation reaching to that tubes. What is the tube? This is the solar radiation, intensity of solar radiation. Tau means tau is the transmittivity of the glass plate. So after transmitting this much of radiation will reach to the absorber. Alpha is basically the absorption coefficient of that blackened sheet. This much of radiation will reach to the water. Then this will be utilized in two ways. One is the heat, that some part of the heat will be transferred from the plate to the tube, fluid is water basically, and another part will go as a loss of the environment. G is the ambient temperature. So by doing some thermal analysis, I decided to compare these two devices, like flat bed collector and evacuated tubular collector. And it has been observed that the evacuated tubular collector gives better performance in terms of thermal efficiency. So nowadays, basically flat bed collector are obsolete in nature, and most of the collectors are replaced by the evacuated tubular collector. This is the solar cooker. It's a very simple design to cook our food. One is the box type, and this square shape or rectangular boxes are there, and this which is black painted from inside to absorb the maximum solar radiation falling in. Two pots are there. First we keep our food to be cooked here in these two pots. Then sun radiation, the direct solar radiation which is falling on this interior of this box gets absorbed, and the solar radiation which will be reflected from this mirrors will be directed towards this pot, and ultimately this is a slow process basically. But basically solar energy is always used as an alternative source of energy. If we don't have the electricity from grid or from other sources, then only we will And another is parabolic disc type collectors. This type solar cooker, you can see a cooker is placed here, and sun radiation falling on this disc will get reflected and will be concentrated towards this. This is the black sheet, black metallic sheet. It absorbs the radiation falling on it, and your food get cooked. And again, it's a very slow process.
So इसके लिए 100 डिग्री से चाहिए सर।
हैं?
उसको बॉयल करने के लिए 100 डिग्री से चाहिए।
100 डिग्री सेल्सियस पहुंचने में काफी टाइम लग जाता है।
हाँ मतलब 100 डिग्री से चाहिए इसको जो टेम्परेचर होगा तो 40 मैक्सिमम
नहीं कंसंट्रेटेड मैक्सिमम नहीं होता है। ये अब 100 डिग्री सेल्सियस की मतलब ब्लैक की 95 डिग्री चला जाता है। ना तो एम्बिएंट टेम्परेचर 40-50 चला जाता है, वाई वी यूज कंसंट्रेटेड। ये solar dryer is a very simple design to dry your crops or some vegetables. It's a kind of air collector. The solar radiation falling on this the glaze surface will transmit it toward this. This is the blackened plate. It gets absorbed. Again, here the difference is that in the previous design we use the flat shell collector to heat up the water, and then water fluid is replaced by air. Again, the same property, the same kinds of crystal will be there. It will start transferring its heat to the air. The air molecule gets heated. It becomes lighter and will rise in this channel. And these trays are there. Here we keep our these crops or vegetables to dry it. And then again, the humid air will exit from this. Solar thermal power. So, based on the temperature what can be achieved, we have three types of solar thermal power plants. Low temperature plants, in which the temperature can reach from 60 to 100 degrees Celsius. Medium temperature power plants, where the temperature can go beyond 100 degrees Celsius till up to 300 degrees Celsius. And high temperature power plant, where the temperature goes beyond 300 degrees Celsius, which are generally used in the solar traditional conventional thermal power plants, where the temperature of the water goes to 500-600 degrees Celsius. So that temperature can be achieved in this high temperature power plants. This is a low temperature power plant where that flat reactor will be used, and we use this in spite of directly using the hot water. We use the heat content of the water with the help of a heat exchanger to boil some other food, and when it go boiling point. And here the butane boilers are used, where the heat of that hot water with the help of the heat exchanger will be transferred to the butane, which has boiling point of around -4 or 0 degrees Celsius. And the superheated steam of this butane gets generated here, and you can run a turbine. Turbine is connected to the mechanical generator by using this generator, and the exhausted steam of that butane will pass through a condenser. Then again it gets liquefied, and in this again it will pump through a channel. This it goes on in this process. The closed loop basically, and it will continue, and it will keep on generating the electrical energy. But it is very low efficiency system. Efficiency is very low. That's why nowadays it is not preferred system. The similar type of working will be here. The difference between the previous design and this design is that we use the parabolic concentrators so that the temperature can go up to 300 degrees. This is the important design, and which are this is basically So let me explain it this simple. This is the schematic diagram of the height of the solar thermal power plants, which are also known as central tower system. Our tower will be there, and these are the heliostats, reflectors basically. These are tracking devices, and the solar radiation falling on it gets reflected towards the central tower system, in which two types of design are there. In one design, we use water as a medium here. Water gets heated, and basically it's the receiver from steam generated, and a superheated steam of this water gets generated here. Here, in molten salt has been used when the temperature goes to 570 degrees Celsius. But if you use water, its temperature goes up to 300 to 400 degrees Celsius. It will be, this is a solar stand. It will be circulated toward the steam boiler or economizer, where the steam is being again in this storage water tank. After in this channel, water is flowing, and we use to generate a stream of water, superheated stream of water. And with the help of that, we use to run the steam turbine, which is connected to a generator, which we use to generate electricity. And in the exhausted steam is closed loop, the exhausted steam of the water, with the help of condenser is converted to liquid, and in this closed cycle, we use to generate electricity. This is a photovoltaic technology. Another technology, when we directly we used to convert the light part of that sun's energy into electricity. This is the photovoltaics. All of us try to do about this photovoltaic effect. It is the photons. If we are calling on some specific material, semiconductor material, where light is converted into electricity. The photovoltaic means light, and voltaic means potential difference. The conversion of light is a very famous system where you can see photovoltaic installation, photovoltaic modules installation. The solar cell went down in 1958. First spacecraft used the solar panels while using satellite method. So nowadays it's a trend to use this photovoltaic modules in spacecraft. So this technology, because of the constant current and voltage, if you want to have some specific amount of current and voltage, we need to connect some numbers of solar cells, either series or parallel, depending on the requirement. If you want more current and voltage in series or parallel, you have this PV module. And then again, if you want more and more voltage or current, then depending on your requirement, you need to connect this number of modules into series or parallel. Then it's added big system where you have to generate say 100 kilowatt, 200 kilowatts of power, and you need to connect such number of panels into array. So two types of system are basically used in solar photovoltaic. When our appliances, this is the DC current. If our appliances are DC, then you can directly operate our appliances. If appliances are DC, AC, like we generally have the DC AC appliances, so you can use an inverter. In most of the houses, we used to have this type of inverter, which can convert to DC to AC. So with the help of this inverter, we can run our AC appliances. If we have some surplus energy, like if during daytime most of the family members are not at house, then we can store this energy into a battery, because in the night time no sun radiation will be there. So the smart way is to, in the daytime, we use direct the sun radiation only to store in the battery, and if surplus energy is getting stored in this battery, then it can be used in the off sunshine hours when no sun radiation is there. Then another is grid connected system. It is the same principle. The only thing is that if we have some more energy, then this energy can be transmitted to the connecting grid. These are a few of the is the very green energy technology and all these things, but some limitations. These are some of the references I